Hello, welcome to Advanced Composites. Today is the second day of the ongoing week, which is the 8th week of this course. Yesterday we just finished our discussion on thermal effects in laminated composite plates, and while discussing these types of plates and also other semi-infinite plates, we had stated that for the lamination sequence 0 to 92, this type of lamination sequence, we had stated that B16, B26, D16, D26 and A16 and A26, for these types of plates all these terms are 0, and these are 0 B16, D16, B26, D26, A16, A26 because it is a cross ply laminate. But we had also specified two additional terms that they will be 0. We said that for this type of plate B12 and B66, they will also be 0. And these terms are indeed 0, but they are not because it is a cross ply. It is not that these terms are 0 because it is a cross ply, it is because the 0 degree and the 90 degree ply are in same thickness and they are at same distance located from the mid plane. So, let me explain. So, this is 0 because we have 0 degree plies and 90 degree plies in same thickness and equidistant on opposite sides of mid plane. Why does that ensure B16 or B12 to be 0? So, let us look at it. So, this is the ply, this is the laminate, this is my mid plane. Let us say this is 0 degree ply and this is 90 degree ply, and let us say there are two plies, each ply is thickness of unit thickness. So, at this point mid plane Z is equal to 0, here Z is equal to -2 and here Z is equal to +2. Okay. So, let us compute B66. So, B66 is equal to Q66 bar times ZK minus ZK minus 1 square into 1 over 2, and this is also for the kth layer, and then I sum it from k is equal to 1 to n. Okay. Now, remember Q66 bar for 0 degree for 0 degree layer is same as Q66 because and Q66 bar for 90 degree layer is also same as Q66, and if you want to show get the proof of it, you please go back and check your earlier equations and you will see that it comes to be same as Q66. So, if that is the case, then what is B66? It is equal to Q66 for the 0 degree layer times, so we will first do for the 0 degree layer for this layer. So, that is 0 square minus -2 square plus Q66 times for the 90-degree layer 2 square minus 0 square, and this entire thing into 1 over 2. So, when I add this is a negative number and this is negative and this is positive, and they are exactly equal in magnitude. So, they cancel out. So, the sum comes out to be 0. So, for this reason B66 is 0, and for the same reason B12 is also 0. So, I did not specify this very explicitly in last few classes, but I thought it is important for all of you to know that B16 and B26 and 16 terms are 0 for cross ply, because all the layers are either 0 degrees and 90 degrees. So, Q16 and Q26 terms for cross ply laminate for each of the cross ply layers is 0, but B12 and B66 is because they are 0 degree and 90 degree ply, and they have the same thickness and they are located on opposite sides of the mid plane. So, this is very important to understand. So, this is something as a point of clarification. Now, we will move on to a new topic. So, we will start discussing finite plates. Finite plates. So, we have discussed infinite plate, now we will start discussing finite plates. So, first we will consider, so that is my x axis, this is my y axis, and let us say my plate is like this. Okay. So, that is my x axis, y, and this is the z axis. So, this dimension is in the y direction is b, in the x direction is a, and we say that r is equal to a over b, and that is aspect ratio. Now, first what we will do is we will once again visit the boundary conditions of these plates, because that is important stuff. So, let us call this edge 1, 2, 3 and 4, and we will just talk about boundary conditions on the x on edge 1 and similar type of boundary and edge 1 and edge 2. So, for edge 1, so this is a recap of earlier stuff. So, nx minus nx plus times delta u naught is equal to 0. So, this is the first boundary condition, which means either nx equals known nx plus or u naught is known. So, each edge will have 4 boundary conditions. The second boundary condition, so this first boundary condition comes from the first equilibrium equation, which is del nx over del x plus del nxy over del y equals 0. From the second equilibrium equation we get the second boundary condition, and that is nxy minus nxy plus times del v naught equals 0, which means either nxy equals a known entity nxy plus or v naught is known on the edge, v naught is known on the edge. The third boundary condition is del mx with respect to x plus twice of del mxy with respect to x no, I am sorry, this is y minus qx plus del mxy del y times del w equals 0. And if you remember, we had said that this term is called qx effective, and it is acting on the positive edge. So, it is I am putting a superscript plus. So, what it means is that either qx effective equals this thing partial of mx with respect to x plus twice of del mxy over del y, or w naught is known. And the fourth one is mx minus mx plus partial of del w naught over del x is equal to 0, which means either mx is equal to mx plus or del w naught over del x is known. Okay. So, this is for edge 1. I can use the same boundary conditions for edge 2, no, edge 3. The only thing is that instead of plus it becomes negative, because that is all, because that edge 3 represents the negative side. So, I just put a negative everywhere. Okay. And then for edge 2 and 4, for edge 2, what would be the boundary conditions? So, I will just not explain, but the boundary condition equations are nxy minus nxy plus del u naught equals 0, ny minus ny plus del v naught equals 0. Then we have del my with respect to del y plus twice of del mxy divided over del x minus qy plus del mxy with respect to del x times del w naught equals 0, and the fourth boundary condition is my minus my plus variation in del w naught with respect to del y equals 0. And similar boundary conditions in form are also for edge 4. So, I will just put also a negative sign as a subscript. Okay. And this thing is qy effective, So, these are the boundary conditions. Now, when we solve for these finite plates, the first thing we should always try to do is try to see if we can make some simplifications. And what are the simplifications we can look forward to? For instance, in case of semi-infinite plates, we made a lot of simplifications. We made one simplification by assuming, because we said that A is very large than B, so all the partial derivatives with respect to y are 0. and that also made another simplification, led to another simplification, that partial derivative of any entity with respect to x equals d over dx. So, these types of simplifications we should always make. So, we should always look whenever, because these plates which are finite in length, their solution procedures are more complicated. Okay. So, we should always look for simplifications and see what are possible and realistic. So, we should always look for simplifications in partial differential equations. You should always see partial differential, whether it is possible or not. What kind of simplifications are possible? Most of the times for finite plates, simplifications in plates, simplifications in these partial differential equations which dictate the equilibrium of the plate, these simplifications are not that much possible, but we should still explore if it is possible. Then we should also look for simplifications in strain displacement relations. So, what do I mean by strain displacement relations? Epsilon x, epsilon y, gamma x y is equal to del u naught over del x, del v naught over del y, del u naught over del y plus del v naught over del x minus z times del 2 w naught over del x square, del 2 w naught over del y square, and twice of del 2 w naught over del x del y. So, we should also see if anything in these strain displacement relations can they be simplified. And once again, in context of finite plates, most of the times we cannot simplify these relations also. The third area to look forward is ABD relations. ABD relations, what kind of simplifications can exist in these things. Okay. So, if the plate is symmetric, so we will quickly cover some of the scenarios for symmetric plates. B is equal to 0. For cross ply plates, cross ply but non-symmetric plates, A16, A26, B16, B26, D16, D26 are 0. For angle ply laminates, again A16 and A26 is equal to 0 for angle ply laminates, but B16, B26 and D16, D26 may or may not be 0. You have to see exactly what is the stacking sequence, but if it is an angle ply, for every theta there is a negative theta and they cancel out each other. Okay. And so on and so forth. So, we have to look at these relations also and see what can happen. And then finally, we should look for simplifications in boundary conditions. This is another area. So, the first step in solving the problem is to see what kind of simplifications we can do, because then we can handle the problem in a less complicated way, and then we actually go around and start solving the problem. So, this is what I wanted to cover today. Tomorrow we will continue with another topic, and also in the case we will start discussing finite plates in much more depth and detail, and till then I look forward to seeing you tomorrow. Thank you.